Welcome back, folks. In today's class, I'll be talking about the normal distribution graph. A normal distribution graph is also called as a bell-shaped curve. Now, if I dissect the bell-shaped curve right into the middle, the middle line, this middle point will be called as a mean point. So this will represent the average of the sample or average of the population, depending upon what we are studying. Now, there are a lot of things which follow the normal distribution graph. Majority of the things, actually, I can say you can put under the normal distribution graph. The prime example can be the what happened in 2020, the COVID. During the COVID time, you might have seen the curve went up and then came down. And another example can be if you open up the any website on the Google, maybe any website of Walmart or Costco, you will see the traffic. The traffic will always follow. There is a bell-shaped curve for the traffic, how it increases during. It slowly starts increasing during the morning hours. Then during a time of the day, it increases up, and then it slowly dies down. Another example can be the height of the people. So majority of the people, I can put it this way. So the average height of a person is certain. Let's say 175 centimeter, and there are percent of people who are above 180, and then fewer people are above 190, and then very few people who have height less than 150 centimeters. So height is another example. Your scores can be taken into consideration under the bell-shaped curve. How the students perform in a classroom also, that can be put under bell-shaped curve. So these were some of the prime examples of a bell-shaped curve. Now I'm going to take an example, again a real life example of the height, and then I'm going to try and study the bell-shaped curve with the help of that. So I'm going to take a sample of 1,000 people. Let's say I went across the different cities in Canada and collected a sample of 1,000 people, and I asked about their height. What is their height? And they gave me a random response, means whatever their height was. And then I collected the data, and from there I calculated that average height of my sample, which was 1,000 data points, was 175 centimeter. This is an assumption I'm taking. So now I'm gonna try and put it under the bell-shaped curve. So the average height is 175 centimeters. So X bar value will be 175 centimeter. That's a mean value. In the last class, we talked about the standard deviation also. Standard deviation. So I'm going to again take an assumption of the standard deviation. Let's say during the data which I collected from there, the standard deviation came out to be 3. And then I'm going to put one standard deviation on this to the left, and then one standard deviation to the right. So if this is 175 centimeter, one standard deviation to the left will be 172 centimeter. Here it will be 178 centimeter. Now, according to the normal distribution graph, anything which follows a normal distribution graph, 68% of the data will lie under the one standard deviation. So my data points, how many data points I had? I had 1,000 data points, so 68% approximately. So what does that mean? So 680, approximately 680 people, their height will lie between 172 to 178 centimeter. This is 172, this is 178 centimeter. And then if I go two standard deviations to the left and two standard deviations to the right, then 84% of the data. So initially this was 68% of the data for one standard deviation. Here it is 84% of the data points lie between two standard deviations. So this is going to become 169, and this point will become 181. So I can say approximately 840 people, if in my sample, their height lied between the 169 and 181 centimeters. And then if I go three standard deviation, so one more standard deviation to the left, so this is three standard deviation, which makes it 166 centimeter, and down here it's gonna make it as 184 centimeter. So 99.7% of the data, 99.7% of the data lies between three standard deviations in a normally distributed graph. So again, if the graph is normally distributed, which I'm assuming in this case is, and one more thing I wanted to tell you, if your sample size is bigger than 30, generally the graph starts behaving in a normal distributed fashion. So the minimum value to get a normally distributed graph is your data sample should be greater than or equal to 30, but I collected a data of 1000 points. So 99% of the data points will be between 166 to 180, I would say 184 centimeter of height. All right. So now this was about the normal distribution graph. Another thing you might have heard about that only 10% of the men or 5% of the men or 15% of the men have a height above the 6 feet and all those things. That's all calculated with the help of this bell-shaped graph. That's how they calculate it. All right. Now that was about the bell-shaped graph. Now, why it is useful, as I told you, it helps us to identify the different ranges, and with the help of those different ranges, we can make a prediction about the data. So hopefully you were able to understand how does normal distribution graph works. I will see you with another video. Till then, goodbye.